Hello all. In this video, I'll solve the second exercise in the resistors chapter. Now, let's read it together. During a laboratory session, a student traces the characteristic current voltage of dipole D to obtain the graph in document 3. Prove that the nature of D is a resistor. So, graphically, whenever we see that the straight line is an increasing straight line passing through the origin, so simply we can say that it is a resistor. So, we say that D is a resistor since resistor, since the UI or IU, it's the same, IU characteristic curve is an increasing straight line passing through the the origin. Okay. Now calculate the slope of the characteristic curve. So mathematically, slope is equal to the subtraction or the difference of YA. We just mention or just sorry, we just pick up 2 points or just 1 point, and we calculate YA minus YB over XA minus XB. YA minus YB over XA minus XB. So it is, let's take this point to 200. Okay, so the voltage is U over I equals 2. The voltage is 2, this point 2, and the current is 200. Oh, but you should notice that the unit here is milliamperes. We should always take the SI unit. Okay, so to convert from milliamperes to amperes, we just divide by 1000. So 200 divided by 1000, it's 0.2. So 2 divided by 0.2, which is now 10 ohms. Okay, now what does the slope represent for the dipole? We know that in the UI characteristic curve of a resistor, the slope represents the resistance of the resistance D. Okay, so now dipole D, which is the resistor, it's called dipole. It's two. It has 2 poles. Okay, dipole D is being put in an electric circuit as shown in document 4 with 2 identical resistors R1 and R2 of resistance 2 ohms each. The ammeter reads the main current of 1 amperes. So the main current here is 1 amperes. And the oscilloscope measuring the voltage resulted in the displacement of 2 divisions above the axis. We say that it's y equals 2 divisions, the displacement. So calculate the voltage UAB read by the oscilloscope if its vertical amplitude gain was adjusted to 4. Vertical amplitude gain is SV, is equal to 4 volts per division. So we have now the vertical sensitivity or the vertical amplitude gain. We have the amplitude, we have the y, 2 divisions. So simply we say U equals SV times y. So SV is 4 times y is 2, which is 8 volts. This is the voltage UAB. Now, calculate R, the equivalent resistance R12 of the resistors R1 and R2. So R12 is equal to R1 plus R2, since they are connected in series. So it's equal to R1, which is 20, and R2 is also 20, since they are identical resistors, which is 40 ohms. Okay? Oh, it's not 4.0, it's 40 ohms. Yes. Now determine the current I1 passing through R1 and R2. We have UAB calculated in part 2.1. We have R12, so we have U, we have R. Simply we can calculate I. So we start by stating Ohm's law, U equal R times I, and we also denote what's the voltage, the resistance, and the current. The voltage here is UAB R is R12, and I is the current. Let's call the current I. Oh, he called it I1. Okay. Now it's we need I1, so I1 equals to U over R. The voltage is UAB, which is 8 volts, over the resistance is R12, 40 ohms. 8 volts over 40 ohms, which is 8 over 4, 2, which is 0.2 amperes. Okay, let's make sure. 8 divided by 4t, of course, it is 0.2. Yes. Here, calculate using the laws of current. The current I2. The laws of current mean either the law of addition or law of uniqueness of current. We need to calculate I2. Note that we have the main current 1 amperes. We have the main current 1 amperes entering point A. R1 and R2 took 0.2 amperes. So what's left in D is the subtraction between the main current and I1. This is, of course, the law of addition of currents in parallel. I equals to I1 plus I2. Law of addition of currents in parallel connections. Okay, we need to calculate I2. So I2 is equal to I minus I1, which is equal to 1 minus 0.2, which is 0.8 amperes. Okay. Note here that the two resistors carry the current 0.2 amperes. So both 0.2 amperes, not 0.2 plus 0.2, 0.4. No, they are connected in series. So the 0.2 amperes passes by both resistors. It's the same 0.2. So it's 0.2 and 0.2, not 0.4. Okay. So 1 minus 0.2 is 0.8. The final question, deduce the resistance of the dipole. Now we have the current of the dipole D, and we have the voltage. Simply we need to calculate the resistance. So R equals to U over I. U is UAB, actually. UAB, and I, it's I2. Okay, I2. Equals to UAB, which is calculated 8 volts over I2, 0.8, 8 over 0.8, it is 10 ohms. Okay, by this we finished the second exercise. Actually, this exercise is a summary for the most of the electricity part covered during this lesson. Thank you for listening, and bye bye.